we are going to revise for our cycle test. Okay. So under this electricity chapter, can anyone say what are all the factors that are affecting the resistance of a material? Raise your hand, those who know the answer. Yes, very good. Neeraj, can you say the answer? Factors affecting the resistance of the material. Louder. Material of the conductor. Very good. Asha, you can say the next factor. Very good. The length of the conductor. Then. Very good. The temperature of the conductor. Then. The last one. Yes. Thickness of the conductor. Clap yourself. Appreciate yourself. So, thank you. So, you can please write down this in your notebook. Factors affecting the resistance of the conductor. Switch off this light. Factors affecting the resistance of the material. So, I want to give you a mnemonic. Okay, a mnemonic for you to easily understand. Okay, the mnemonic for this question is MLT power 2. Okay, MLT power 2. If you remember this, you can easily write the answer. But you are not supposed to write this mnemonic as an answer. Okay, where M stands for material of the conductor and L stands for length of the conductor, where T square in that one T represents thickness of the conductor and the other T represents
temperature.
Very good, temperature of the conductor. So you can remember this, but not supposed to write this mnemonic in the answer sheet. Okay. Can you proceed to the next one? Who's that? And yes, you can ask. While affecting the resistance, this ml per peak was square is enough. Thickness is referring to area of cross section. Proceeding now, the very first question. A wire of length L made of material resistivity. Here it is mistakenly typed as R, but resistivity is represented by the symbol rho. Very good. Rho is cut into two equal parts. Okay, they are taking a wire of length L and cutting into two equal parts. What about the resistivity of the two parts? Okay, so what we should do for finding out the resistivity? What is the formula for finding out the resistance? First, let me go from resistance, where R is equal to rho into. Can you all remember what we have discussed in our last class? What is the formula for resistance? R is equal to rho into L by A, where rho is your constant. Okay, what is the name of the constant? Rho. Rho means it denotes resistivity. It denotes resistivity. Please go through the paper and say resistivity. What do you mean by L? Length of the conductor or any other material. Okay. A means area of cross section. So R refers to resistance of the material. I told on the day where resistivity depends only on this one. What is that? Very good. Material resistivity only depends upon the material of the conductor. Okay, it depends only upon the material of the conductor. Okay, purely you write again one more time for your revision purpose. Purely depends on the material of the conductor, and it won't depend on any other dimension or factor. Okay. So, then the first question they are saying it as I gave a wire of length L which is having resistivity rho. Everything they are saying and if it is cut into two equal parts, what will happen to resistivity? Yes, very good. It will remain the same. Even if you are cutting to two parts or four parts, it will remain the same because resistivity depends upon the material alone. Can you understand this? Can you proceed to the next question? Yes. So here comes your second question. The temperature of a conductor is increased. The graph best showing the variation of its resistance. So here in the graph they are discussing the relationship between temperature and resistance. What will happen if you increase the temperature? What will happen to the resistance? Resistance will also increase. Very good. Can anyone say the reason? Okay, directly proportional. How it is directly proportional? That day we have discussed, Emily, by drawing the diagram. And you have done a very good example, Emily. You portrayed what will happen if you are increasing the area, if you are increasing the thickness. Emily, so what will happen if you are increasing the temperature? You are increasing the temperature in x-axis and resistance in y-axis. Okay. If you are increasing the temperature, what will happen? Very good. Kinetic energy will increase. Then molecules, atoms will move faster. Okay. What about collision or hitting? Or hits that we have discussed on the day? Collision will be more or less? More. Very good. Collision will be more. If the temperature is more, what will happen? Can you all remember this diagram? Yes. If the temperature is more, the collisions or hits or vibration will be more. Can you recall this diagram? Yes. If you increase the temperature, this resistance, what it will do? It will oppose the flow of electrons. Am I right? It will obstruct the flow of electrons. So while it is obstructing the flow, it will hit again and again on these atoms and free electrons. So they will start to vibrate from its mean position. So that vibration will be generated as heat. Very good. Heating effect of electric current. Okay. So temperature increases, resistance increases. So which graph will purely represent my answer? A. But what about the C? Option C. Here A, it's a linear graph. Am I right? But in option C, if you look here, it is increasing gradually. Am I right? After some time only it's increasing like anything. So whether it's A or C, both the cases are representing. Am I right? If you increase the temperature, resistance also increases. But which one is correct for my case? The linear graph. A only. Am I right? The linear graph only is my correct. Okay. It won't deviate here and there during my experimental. Okay. So it's a A. Hope you are clear. Any doubts?